Hey y'all, today we are going to talk about writing rules from tables. So go ahead and get your paper set up, hit pause if you need to, and we will get started. Here are a few tables that I want you to have ready. Now, let's go ahead and get started. Writing rules from tables. First of all, what is a rule? All rules should be written in the form of y equals mx plus b. Y equals mx plus b. Now, let's remind ourselves what each thing is. What is the b? B is your initial value, and m is your slope. We also call that rate of change. That's also our rate of change. Now, one tip that I will tell you about writing rules, y equals mx plus b, anytime you're working with tables and you're trying to find the rule and write the rule, you always want to look for 0 in the x spot. So look for 0 in the x spot. All right, so what do you mean by look for 0 in the x spot? Well, let's go ahead and get started with one of our practice examples, and I will help you determine what exactly I'm talking about. So look at this first one. Let's fill in the numbers -2, -1, 0, 1, and 2 for the x spots. -2, -1, 0, 1, and 2. For the y spots, I want you to fill in -2, 1, 4, 7, and 10. Now, what I mean by look for the 0 in the x spot, look at your x part of your table, your input. Do you see that 0 in the x spot? You're always going to look for that. That is your initial value. If you were to graph this, that would be your y-axis, your initial value. So when you're writing a rule, you know that your b is your initial value. So writing a rule for this particular table, we already know something. We know that our initial value, our b, is going to be 4 because it lines up with 0, which is your y-axis. So let's go ahead and write a rule for this one. Y equals, we don't know our slope yet. We don't know our rate of change. We've got to figure that out. So y equals something x plus 4. Now, how was I able to get that plus 4? Because it lines up with a 0. Now, to find your slope, you need to create little loop-de-loos. So on each one of these x's, we're going to determine the difference between it. How much is it to get from -2 to -1? -1 to 0. 0 to 1. 1 to 2. Okay, so you're adding 1, adding 1, adding 1, adding 1 every time. Look on the bottom. How much of a change from -2 to 1, so that's plus 3, 1 to 4, plus 3, 4 to 7, plus 3, and 7 to 10, plus 3. So another tip you need to write down is you always determine the slope by getting your change in y. Well, what was the change in y every time? 3. Over your change in x. 1. So another tip, find the change in y, and you're going to put that over the change in x. So the change in y over the change in x. Let me darken that up just a little bit. The change in y over the change in x. So that's how you determine your slope. So our tip, look for the 0 in the x spot. That was to help find our b. And then the change in y over the change in x, that helps us find our m. All right, so now let's go back to our table. What was our change in y? What was changing every time in y? It was doing what? Adding 3. So 3 over, what was our change in the x every time? Every time it's adding 1. Well, what is 3 over 1? 3. That is your slope. So the rule for this table, y equals 3x plus 4. All right, let's work with another table. Let's look at this table here, and notice that my tables are all different. When you copy these down, it's okay. You can have horizontal tables or you can have vertical tables, either way. Let's fill in some numbers for this graph. Excuse me, this table. -2, -1, 0, 1, and 2. We're going to use those again. On the bottom, -1, -3, -5, -7, and -9. Now, do you notice anything? What can we immediately write down? There is something with the 0. Absolutely. -5. So we'll go ahead and write down y equals something x minus 5 because it is there. -5. Now we've got to figure out our m, our slope, our rate of change, what's happening every single time. So on the top, do your loop-de-loos. What's happening? You're adding 1 every time. Good. What's happening on the bottom? It is subtracting 2. Okay, so the change in y over the change in x, what is changing in y every single time? What is happening? -2 over what's happening on the top every time in the x's. 1. What is -2 over 1? -2. So your rule is y equals -2x minus 5. Now, let's look and see what happens if we do not have a 0 there. So we've been looking at our initial value is present for us. It is in the 0 spot every single time. But what if it is not in the 0 spot every single time? We've got to figure out what is happening. Let's fill in a table. I want you to go ahead for your first few numbers. I would like for you to write down 2, 3, 4, 5, and 6. 2, 3, 4, 5, and 6. For your y values, let's write down 18, 22, 26, 30, and 34. All right, let's see what's happening here. We do not have a 0 in the x spot. So we're actually going to have to create that. We're going to have to back up. Well, look and see what your x is going by. What is this going by every time? A 1. So if you do your loop-de-loos, it's adding 1. So can we back up and create a 0 spot? Yeah, absolutely. What plus 1 makes 2? A 1. And then what plus 1 would make a 1? 0. So if we back up, we're going to figure out what goes with that 0 spot. But we've got to do our loop-de-loos over here to figure out what it's doing every time to be able to back up. So 18 to get to 22 is plus 4. 22 to get to 26, plus 4. 26 to get to 30, plus 4. 30 to get to 34, plus 4. So what would we need to do? What plus 4 would give us 18? 14, yes. But that's not at the 0 spot. That's with the 1. So let's back up again. What plus 4 would give us 14? 10. And that lines up with the 0 spot. And the 0 is what part in your rule? The initial value, the b. So can we write a rule for this now? Absolutely. Y equals, I know that my 10 lines up with my 0 in the x because I went backwards to find it. So something x plus 10. Well, we already figured out what that something is. What was your change in y every single time? Adding 4. What was your change in x every time? Adding 1. What is 4 over 1? 4. So y equals 4x plus 10. Okay, let's do one more and see if we can understand. Let's fill in these numbers. I want to go ahead and put 2, 4, 6, 8, and 10. Now, what if all of your values are not present? What if we are missing a few of our values? So what if we have a 15 here, and then we have a 19, and then we have a 27? Okay, we need to figure out what is happening every single time to be able to fill it in and create a rule. So let's see what we're working with. I notice there's nothing 0 here, so I'm going to have to create a 0 spot. But in order to do that, I've got to find out what is happening every time. What's happening on the left every single time? You're adding 2 this time. Good. So plus 2, plus 2, plus 2, plus 2. So in order to create that 0 spot, what plus 2 would give me 2? Good, 0. We'll go ahead and put it just right above the graph so we can see it clear. So 0 plus 2 gives you that 2. Now, let's go ahead and look on the right side. What is happening every time in the y's? We're not working with very much, but we can see 15 to get to 19 is how much? Plus 4. Okay. Now, what is 4 change in y over the change in x? What is 4 over 2? 2. So this should be going up by 2. Now, let's double check that. 19 to get to 27, but do not take a 2 over here. You're going to have to go around and go from that 6 down to that 10. So to get from 6 to 10, skip over the 8 because we don't have a hole we do have a hole right there. We don't have a number. From 6 to 8, that was plus 4. So what's going to happen from 19 to get to 27? Plus 8. What is 8 over 4? 2. Good. So if you reduce these, you notice that 15 to 19 was 4. Over the 4 to 6 was 2. So 4 over 2 equals 2. Well, look at this huge jump, this huge loop-de-loo we made. 19 to 27 was 8. Over 6 to get to 10 was a huge jump of 4. They both equal how much? 2. So even if we skipped a block because we don't know what's there, we know that it's still increasing by 2 every single time. So what is going to be our value here? Is it going to be 20, 21, 22, 23? What is it going to be? It is going to be 23 because this particular graph is increasing by 4 on the right side. This table is. But in order to go backwards and find your 0, we're going to have to decrease 4. So how much is going to go with the 2? 11. Good. And what would go with the 0? 7. So can we write a rule for this now? Absolutely. Y equals, what was happening every single time? Please do not say 4x. It was increasing by 4, but it also is increasing over here by 2. So don't forget, you had to reduce that. 4 over 2 makes 2. So y equals 2x. And then we went backwards to find out what lined up with 0. Plus 7. Okay, let's try one more example. one more example. All right, so in your x values, go ahead and fill in your x's with 1, 2, 3, 4, 5. And in your y values, go ahead and fill these in with -2, 0, 2, 4, and 6. Okay, do we have anything visible ready for us immediately? I hope you are not saying the 0 spot, because remember, in your tip, it says look for the 0 in the x spot. Is there a 0 in the x? No. There is one in the y, but you are not supposed to look at that. You need to look in the x spot. So we're going to have to go backwards and create a 0 spot. Now, let's determine what's happening every single time here so that we can create an equation. So what is happening each time on the left? +1, +1, +1, +1. What's happening every time on the right? +2, +2, +2, +2. So what is the change in y? 2 over the change in x? 1. What is 2 over 1? 2. So we know the first part of our rule. The first part of our rule is going to be y equals 2x, but now we got to go backwards and figure out what lines up with the x 0. So if we go backwards, what plus 2, because you're putting it over here, what plus 2 gives you -2? It is -4. Good. -4 plus 2 gives you -2. So now do you know what lines up with 0? -4. That is not the same as what you would have picked if you just automatically looked for the 0. Always look for the 0 in the x spot. Hope this helps. Y'all have a great day. Bye.